For the course project, the problem that I've picked is the ability to pick which machines are going to fail proactively in a data center. This is an important problem because in a data center, there could be hundreds, thousands, even millions of hardware components that are expected to fail. And especially if you're a big hyperscaler provider, this is a huge problem because any of the component failure could be downtime for you, which is a revenue miss and leads to unhappy customers. So it is an important problem from a business perspective. And given the structured nature of components within hardware, the ability to measure various parameters, including things like heat, performance, capacity, so on and so forth, this seems like a very good problem for machine learning, and it's a very good prediction problem that has high business impact as well as high feasibility. In terms of success, what we want to be able to see is for the cohort of machines that we are predicting, we're able to replace more of those machines that are expected to fail more proactively, leading to fewer machines that are failing in productions compared to, let's say, a control group that doesn't have any of this ML predicting capability applied to it, which is also known as a control group. And so, with that as kind of the background, the types of machines that could potentially be in a data center and the subcomponents include things like CPU. It could also include GPUs and machine learning hardware. It could also include memory, hard drives for storage, and as well as supporting infrastructure such as power and cooling. Some of the features that we'll be interested in looking at include useful life of each component. What is the current life at? What is the capacity at which these things are being run at? Is it hot or cold? Things that are run hot more periodically tend to fail more frequently, as well as we'll want to take a look at whether there's a relationship between the supplier who has provided a particular component and the failure rate. There's likely external factors that also lead to component failure, things like fire, water leak, earthquake, or electromagnetic wave disruption. We're not going to focus on that just to keep the model simple, but these are some considerations to think about. One additional thing I would want to do is speak to a data center operations expert. Given that, roughly a very small percentage of components are likely to fail, given the total fleet, there is a bit of a class imbalance going on. But given that it's a hyperscaler type problem, you would expect to find a large volume of these failures, even though the probability itself might be small. In terms of modeling, a regression seems like a good approach to start, followed by perhaps a random forest as a next example. One of the considerations is you don't want too many false positives in this type of modeling, in which case you identify good machines as potentially bad and you throw them away. That leads to opportunity cost, right? At the same time, false negative should also be kept low, which means you don't detect machines that could potentially be bad. There is tolerance here because customers do have SLAs. We don't expect machines to recover with zero downtime. There is that little bit of a budget in terms of when things need to come back to time. So I believe there can be a little bit of a toleration from a business perspective in terms of both false positive as well as false negativity rate.